Good evening, everyone, and thank you for joining us. The first Kubernetes meetup here at the True office. Thank you. We have two talks tonight. The first is our own cosmonaut, Alexander. He's going to talk about building Kubernetes as a service at True and what we encountered. We have Leon from JFrog, who's going to talk about a Kubernetes-powered Go modules repository.
Hello? Cool. So to start off, I'm going to ask you guys a few questions. Who is running Kubernetes in production today? Ooh, that's a lot. That's awesome. Okay, so who is building apps using Golang? Okay, nice, nice. That's slightly less than I had expected, but still. Oh, and obviously, who knows about JFrog? That is definitely less than I hoped for. So obviously, I'll hope to remedy some of that during the presentation. And so for everyone that does not know Golang, I want to take you to on a trip through history, essentially, and talk a bit about Go. Any Java developers in the house today? Okay, that's actually less than I anticipated. .NET. Node.js? Okay, I see a lot of Node.js people there. Awesome. The reason why I ask will become clear in a second. Trust me on that. So as you look at Go, to me, Go is one of the most awesome languages, as it combines a ton of stuff from all the languages I just talked about. And it started off in Google a few years ago with the first major milestone, their 1.0 release in 2012. The second major milestone, at least from my point of view, was the 1.5 release in 2015, which had two super awesome things. It was the first release where everything was built in Go, so there were no external dependencies on C anymore, with the obvious exception for CGO. And the other thing, it started supporting vendoring. And vendoring is an essential concept of Golang that we'll talk a bit about today as well. So third major milestone, 1.8, 2017, it started introducing Go plugins. And for everyone that does not use Golang but has used any other programming language, then plugins are essentially the jar files. They are the NuGet modules, you know, the stuff that you use to build your apps. And then in 1.10, they made a ton of changes in the toolchain, the runtime, the libraries, and did a bunch of other awesome stuff. And as you look at all their release notes, there is one massive thing missing, at least from my point of view. The one thing that is missing through all of this is dependency management. As you look at, for example, Node.js, if you look at Java, who does dependency management with either NPM and the package JSON, or things like Maven, there is an awesome way to do version management. There is an awesome way to do dependency management. Golang does not have that today, or almost. And if you look at Christopher Bullock, who said, it is impossible to be sure of anything but debt and taxes. I think that if he was alive today and he was a software developer, the quote would be something like, it is impossible to be certain of anything but debt, taxes, and software dependencies. Because who builds applications without any third-party libraries? Wait, we actually have people who... That is awesome. I really want to talk to you guys after this to learn about that. So Go realized that they had to do something because, you know, building a language with no dependency management in there is not that great. So in 1.11, they added support for Go modules. And Go modules is essentially a great way to do version management. Why? So first of all, by the way, it's the official way to do dependency management. So if you're a Golang developer and you use anything else, then you might want to look at moving into Go modules. The other thing which is super awesome to me as a developer, it no longer relies on GoPath, so I can pretty much develop my Go applications anywhere on my machine that I want to. I'm no longer restricted to one single folder. And everything is embedded in one single tool. I mean, I don't have to install a bunch of different version management systems, a bunch of different dependency management systems, and the Go client. I can just do everything through Go. Now, the question is, if you've done this before, then probably you've, and this was one of the highlights that I talked about, then you've used something like vendoring. And great question, why not use vendoring? I mean, in essence, we've done this before. It works, so why shouldn't I do that? And if you look at vendoring, what vendoring actually is making a literal copy of all the source code that you're using. And that is a bad idea. Because that actually means that when you're building your app, when you're putting it into something like GitHub or whichever version control system that you end up with, you're essentially making a hard fork. You are now responsible for not just managing your source code of your application, but you're essentially managing someone else's source code too. Who all is an application developer here? Good. So when I say that you should only be managing your own source code and not someone else's, everyone agrees, right? Good, good. I'm happy that everyone is still awake. So it actually means that within software, immutable and repeatable are two incredibly important aspects. Why is that? Well, first of all, if you look at immutable dependencies, then it allows you to create builds that are always going to be the same. If you rely on vendoring, if you create that hard copy of someone else's source code, then that also means that someone can do a force push in order to override what's already in GitHub. And that will be a terrible thing. The other thing is lost dependencies. I mean, for the Node.js developers, who all were affected by leftpad when that disappeared from GitHub? Right? Yes, I see someone. That was a big problem. So that's not a great idea to have everything on GitHub. And trust. I mean, who here trusts their colleagues? Just making sure, just making sure. Okay, if you're sitting with your colleagues and someone did not raise their hand, just saying, that's going to be an interesting discussion tomorrow morning. Okay, so I'm going to assume everyone trusts their colleagues, but what about the rest of the internet? I mean, do you trust that single developer down in Australia? Do you trust that developer team in Brazil that's making some awesome dependency that you're relying on? Maybe. I mean, it's probably good practice to do so. But what if they, for some reason, decide to remove their source code from somewhere? That's not a great idea. So we need a place to store everything. We need a place to keep all of our modules safe. And that is what Go Center is. So by the way, if anyone's wondering who that person up on stage is, this is me. I'm a developer advocate at JFrog. I'm passionate about all things serverless, containers, and generally all things in the cloud. And especially if you bring all of those together, then I love that. I love dad jokes, cheesecake, and API. So I'm going to guess that cheesecake and APIs are sort of familiar within this audience. Who all knows dad jokes? That is actually pretty much what I expected. So for everyone who doesn't know that, I decided to put a bit of humor, or at least an attempt to put a bit of humor in my slides as well. So my favorite dad joke: what do you hear when you hold a Unix terminal to your ear? Deafening silence. Anyone? You can hear the sea. Thank you. So thank you. Those are dad jokes. I love them. So let's talk a bit about Go Center, because that's the actual thing that we want to talk about, because that is the thing, the application that we build on top of Kubernetes. And Go Center is essentially a Go repository free for everyone to use, because we wanted to make sure that whoever wants to build apps using Golang and wants to use Go modules, which you absolutely should if you use Go, then you should have a free central registry that you can make use of. So you can obviously find your the modules that you're looking for and download it from there. Now, how did we get to Kubernetes? Because in essence, this is the central thing that we're talking about. We made a very deliberate choice to go with Kubernetes essentially for two reasons. First off, we wanted to make use for this project, I should say. We wanted to make use of a proven orchestration platform. I mean, and as I was asking just now, who all is running Kubernetes in production, a lot of hands shot up, simply because it is the de facto standard to running container workloads. Everyone is using it. And obviously, there are a ton of out-of-the-box features that you want to be using. I mean, Alex did an amazing job talking about that just now, so I'm not going to repeat that. So we decided to build our stuff on Google Cloud Platform. That was their really nice logo over there. Why? Simply because it's the most mature Kubernetes offering managed Kubernetes offering that exists today. Maybe True will change that, and then we'll obviously consider moving. So why also? It's really easy to deploy. I mean, there are a ton of existing tools, there are a ton of existing techniques to deploy, and Google Cloud Platform supports all of that. So that is why we decided to use theirs. And it comes out of the box with a ton of awesome troubleshooting tools. Things like BigQuery, things like Stackdriver. Who all is using Google Cloud Platform? Okay, a few. AWS? Okay, that's a lot more. Azure? Huh, not as many as I expected. Okay. But if you're deploying to any type of Kubernetes platform, there is a very important thing that Alex touched on in his presentation as well, is maintaining state. And I mean, who actually needs state anyway? Isn't it the thing that we decided to do something with these 12 things? Who recognizes this? These are the? Yes, exactly. Thank you. These are 12-factor apps. So as I talk about how we went into Kubernetes, the stuff that we built that runs on top of GCP, you'll see some of those 12 factors come by as well. And why? Simply because we didn't want to build everything ourselves. I mean, we want to add value where our engineers add the best value, and that is focusing on the project and not on things like building a database. Who has built a database here before? Good. I see little hands go up. And that makes total sense. I mean, why would you? Why wouldn't you use something like Postgres, MongoDB, or any of the existing databases that are out there? It makes total sense to do that unless you're a database engineer. It makes total sense to use a messaging platform like PubSub, like we use for GoCenter, simply because the guys that built that's what they do for a living. We don't. And it also makes it a lot easier to upgrade because we simply use the latest version that they have available for us. So when we do deployments using Helm. Why? Simply because Helm charts a version, so you know exactly what you're running in production. You know exactly the version of your microservice that you have. It also doesn't really hurt that one of the co-founders of Helm joined our company to really make sure that when we build our products that we use the best practices that his and his team set out to build. So some of those best practices that we learned while building those microservices are the ones that are behind me right now. So probably the most important thing is setting limits and adding labels to your deployments. Labels obviously make it easy to select stuff as you're managing your cluster. Limits are really, really useful to make sure your cluster doesn't die. And yes, we found that out the hard way. Obviously, doing things like secrets, because who wants to have hard-coded passwords in their apps? I saw one person saying he wants hard-coded. Okay, that's great. And you probably want to have different namespaces, different clusters to do things. And the way that we set it up, and we'll get to that in a second as well, is we set it up that every namespace that you deploy into, that you create within Kubernetes has their own task. So we have things like an admin namespace. We have things like a logging namespace, a monitoring namespace, simply so that we can make sure that every aspect is covered. So how did we build our infrastructure? And for people that know JFrog, we're kind of big on building pipelines and doing promotions and stuff like that. So when we build, everything goes through a CI server. And in our case, we went with Jenkins simply because that's the one we knew very well. As we build our Docker containers, the ones that actually go into production, it sort of follows this pipeline. So it goes into integration, it goes into system testing, but only if certain quality requirements are met. Simply because we want to make sure that we provide our community with the best that we have. And as you look at our entire infrastructure, right now we have 5 clusters running. So that's all about the dev prod parity. I mean, we have a cluster for production, obviously. We have a bunch of clusters for testing, and we have a bunch of clusters for development. Our development cluster is probably the biggest, where pretty much every developer gets to have their own complete installation of GoCenter so that they can test out their code, their feature branches. And that is probably one of the things that we learned, is that as you want to test, having dev prod parity, having the exact same setup, even if it is a bit slimmed down, is incredibly, incredibly important. So we have a few microservices. In fact, we have 6 of them. And I want to introduce you to all of them so that as we go to the next slide, you sort of have a feeling of what it does. So first off, we have the discovery microservice. And as the name implies, it discovers new Golang projects. So it essentially goes out to GitHub, finds the most awesome projects that exist, obviously based on stars and things like that, and sends it to the processor. The processor then takes care of making sure that certain criteria are met, so that it has a license, because licenses are really important, that it has in fact the right number of stars, things like that, that you can actually do a go-get for it, because that is pretty important. I mean, how terrible would it be if you were to try to get a module that ended up not being a proper Go module? Terrible thing. So the notifier, as the name kind of implies, notifies our operations teams if something is going wrong. Because we highly believe in having relatively autonomous clusters, but they need to check in with our teams every now and then. So the other 3 that we have are the validator, the backend, and the UI. And as you could see on the previous slide and this slide, most of our stuff is built in Golang. The only exception is the UI, which is based on Node.js. So when we build GoCenter, we obviously drink our own champagne, and yes, we use GoCenter to build GoCenter. So as you look at how our cluster looks like, this is sort of what it does. And as you can see, there are the exact same pictures where the user talks to the web UI then talks to that backend server, and all of the communication is done through Google Pub Sub, simply because that helps us with scaling. And scaling is one of those things that comes out of the box with Kubernetes, but one of the things that is incredibly important as you grow with your project. And then up there, you see things like Slack, things like GitHub, and obviously for the people that know JFrog, we obviously use Artifactory a lot, simply because that is where those Go modules end up in. As you start out with testing, probably the most interesting test that you can do, at least from our point of view, is a load test. Because it not only tests how your application is going to be able to react under a certain load, it's also going to be able to tell you how well your Kubernetes cluster is able to scale. So for us, we tested our UI with about 10,000 users simultaneously doing a bunch of requests and making sure on our end that everything was still properly running. The other test that we did is we loaded our backend with about 10,000 modules twice, simply to see what was going to happen. So if you look at the bottom graph there, you see a bunch of spikes where the load was high enough, and you see those troughs as our Kubernetes cluster scales. Just out of curiosity, who does chaos engineering? Nice. That's pretty cool. So we do chaos engineering too, and I have to say we do chaos engineering for the poor. When I say that it's for the poor, it essentially means we wrote a bunch of shell scripts that every now and then try to kick out a node, a pod, or any of those things, and essentially make sure that our cluster heals itself again. And as our cluster heals itself again, it will actually tell that to our operations people, so that as they're looking at what they're doing, or what our cluster is doing, that they're sort of aware of what is happening. So how do we run that at scale? I mean, running 5 clusters that serve an entire Go community of about 1.5 million developers, that's going to require some nodes. So we have 2 node pools, and yes, node pools are definitely the place where our nodes can relax a bit as well. Thank you. I heard some laughs. Good. However, in this case, the node pools are obviously the GCP node pools, and we essentially chose to go with preemptible VMs simply because it totally helps reduce our cost. By the way, for people who don't know, preemptible VMs are the VMs that Google can shut down. Obviously, when you're running stateless apps, that is awesome because in that case, it doesn't really matter. One goes down, one comes up. And since state doesn't matter, we're all good. There are a few exceptions to when we're not using those preemptible VMs and just using more or less stateful machines, if you will. That's first of all for a production cluster because it's kind of scary when you're first going out and running a new project in production. With such a big load, we really wanted to make sure that everything was going to be running all the time. And as we're more confident in how our cluster reacts, because we obviously monitor that using a ton of stuff, we are looking into moving some of that to the preemptible VMs. So as I talked about, we did a bunch of things using Helm, essentially making sure that we set our resources, we set our limits, and probably the thing that I found most interesting, simply because I didn't know that before I helped out with this project, is setting node affinity as well. So we actually make sure that as we learn through those load tests, which are the most heavy used microservices, that we sort of spread them out through our collection of nodes. And then the pod anti-affinity is, sometimes it actually happens that our cluster is so busy that every node is utilized. And then we start to have to wonder which of the services are we going to degrade first, and that is where this comes in. That comes in very handy. Just like True did, we love to keep an eye on what our nodes are doing, what the traffic is, and exactly like True, we're using pretty much the same stuff. If everything goes okay and the internet is going to work, I'll show you a quick overview of our Kubernetes dashboard in a sec. Now, one of the things that is really important in 12-factor apps is that you have one single thing running in your apps. You have one process. However, there is one slight exception because sometimes our containers get a bit lonely. So the only microservice that we have that has 2 containers within a pod is our UI microservice. The reason that we did that is we added an Nginx container in there simply to make sure that all the HTTP traffic and all that kind of handling was done by the Nginx container, so that our UI developers could focus on what they do best, build an awesome UI that people want to use. So as I said, we do want to keep in touch with our nodes. So we make heavy use of a tool called Cube Slack. Who all uses Slack here? Wow, that's a lot more than I expected. Nice. So I don't have to explain what Slack is. That's good. And we use Cube Slack so that our Kubernetes clusters can inform our operators or our DevOps teams what is happening within the cluster. So when Jenkins, which we use for our builds, starts a build, they actually say on one of our channels, hey guys, we're going to upgrade this, so as you see stuff happening, don't be too alarmed. Then you see a bunch of things of where pods are ready, unready, and being scheduled. And ultimately, Jenkins is also going to tell you when the upgrade is done, so that as one of our teams pushes a new feature, pushes an update into production, everyone within the company, everyone that has subscribed to that Slack channel, can see what is happening. So the cool thing is that if our CTO, who is very big on being technically aware as well, wants to see what is happening within our cluster, he just goes to that channel. When I want to see what is happening because one of my modules isn't being included, I can go to that channel and see what's happening, which is probably my most important feature. So as we talked about scaling, we essentially scale on our clusters on 4 different levels. First off, we do node scaling so that our nodes get provisioned whenever we need to. We have a collection of, or a maximum of 25 nodes that we can use. And depending on how busy it is, they scale up or scale down. And obviously let Kubernetes manage the where all the pods are going to land. Because that is, to me, one of the most awesome features that Kubernetes has out of the box. And one of the reasons why we went with Kubernetes, simply because it does that. Now, the probably most common reason to scale is obviously compute. So based on CPU usage of our containers, we scale things up or scale things down. If one microservice gets super busy, then we add a few. If that collection of microservices is less busy, we essentially scale them down. The other thing is based on messaging, and as I said, most of our cluster talks to each other using message-based systems. So if a queue where messages land is getting a lot of traffic, for example, because a lot of people are trying to add new modules into GoCenter, then we scale out scale up, I should say, the microservice that is going to be responsible for that. And as soon as the queue is less busy, then we obviously scale them down too. And as I said, what goes up must come down, usually speaking. And that obviously only goes for containers. Your microservices themselves should not go down. That made sense, right? Okay, just making sure. And we dare to dream. I mean, for us, GoCenter was or at least what is in production now, was sort of the first step of what we wanted to do. And I did want to talk a bit about what we want to do within GoCenter. And it starts with chat ops. So we love Slack. And we do a ton of stuff within Slack, from seeing our builds, as you could see on screen, to congratulating people whose birthday it is, because that's good for morale. The other thing is that we want to make sure that our DevOps teams who use Slack day in, day out to communicate, simply because we have a distributed company, that they can use Slack to take control of the Kubernetes clusters, take control of the deployments, take control of seeing what happens within the cluster. The other thing is that, as you may recall from under the slides, right now Artifactory sits outside of our Kubernetes cluster, and we really want to get it in there. So Artifactory runs on a separate cluster, simply because if you want to scale Artifactory, by the way, who uses Artifactory? Okay, really? Only 3? Okay. So as you want to scale Artifactory, one of the most common reasons to do that is based on network traffic. And right now, Kubernetes does not allow you to scale based on network traffic. It allows you to scale on a ton of other things, except the one that really matters for us. And the obvious thing is we want to have your feedback. I mean, to me, as a developer advocate, I think I have an amazing job that I get to talk to all of you. And I really want to know your feedback. I want to know what we can do to make our projects better. So in order to do that, you can obviously tweet at JFrog. You can tweet to me personally at Leon Stigter, or at Leon Stigter for our Dutch colleagues here. And the nice thing is I'll actually tweet out a link to the slides, so everyone that took pictures, that is super awesome, though technically illegal with the new copyright laws that the European Union just passed. Thank you, yes. But I'll allow it. So if you send a question to either of the two Twitter handles, we'll make sure that you get a response. So, any questions so far? So GoCenter is free to use when you go to gocenter.io. It's a public registry of Go modules. Free of charge, using the exact same tools that you would use for normal Go development. So no additional tools you need to learn, no additional licenses you need to get from us or anyone else. Good question, and thank you for asking.
Well, give him a big hand. Thank you very much, Leon. Thank you very much for joining us here tonight.